Heat engines and second law of thermodynamics. According to the first law of thermodynamics, heat and work are mutually interchangeable. This law does not mention about the direction flow of heat. Second law of thermodynamics gives the direction of flow of heat energy. Before stating the law, let us see how heat energy is converted into mechanical energy in a heat engine. Heat engine is a device used for converting heat energy constantly into mechanical work. The schematic diagram of a heat engine is shown here. The three essential parts of a heat engine are source or hot body, working substance, and sink or cold body. The working substance is taken along a cycle of operations. In this process, the working substance absorbs heat from the source, transforms part of it into mechanical energy, and the remaining part of heat is rejected to the sink. After completing the operation, the working substance comes back to its original state. Heat energy is never converted completely into mechanical energy. That is, efficiency of a heat engine is never equal to 100%. Thus, we can define efficiency of an engine as the ratio of external work done to the amount of heat absorbed from the source. In heat engines, the working substance takes heat Q1 from source at temperature T1, rejects the heat Q2 to the sink at temperature T2, and does some work W. Eta is equal to Q1 minus Q2 by Q1. Eta is equal to 1 minus Q2 by Q1. There are two types of heat engines. They are internal combustion engine and external combustion engine. Petrol and diesel engines are internal combustion engines. Steam engine is an external combustion engine. Click on the link provided to see the working of an internal combustion engine. The fact that heat energy is never completely converted to mechanical energy has become the second law of thermodynamics. There are several equivalent statements of the second law of thermodynamics. Lord Kelvin stated, "It is impossible to construct a device operating in a cycle for the sole purpose of extracting heat from a reservoir and changing it entirely into an equal amount of work without rejecting a part of the heat." This statement simply means an engine can convert only a part of the heat energy into mechanical work. Clausius' statement: "It is not possible for a self-acting machine, unaided by any external agency, to transfer heat from a body at low temperature to another body at higher temperature." This statement also means no heat engine is 100% efficient.